Okay. Let's take a quick look at those, all right? And let me see here. Okay. Now, this one here, number 13, basically the idea was you were finding the percentage or the probability just like you would of any of the other problems, but then you took that percent of either the number, of the number of working days, okay?
Okay.
So, for example, 18,000 is one standard deviation below the mean, so you got 16%.
Okay.
You would just take 16% of 260 days to get the number of days, okay? And the others are like that as well. This one, let's take a little closer look at. There's a little more to it. It says, when a specific variety of radish is grown without fertilizer, the weights of the radishes produced are normally distributed with a mean of 40 grams and a standard deviation of 10 grams. So before we move on, let's go ahead and draw our normal curve for the radishes grown without fertilizer, okay? So we'll use blue for that. We want a mean of 40, so I'll put 40 here. And it said the standard deviation was 10, okay? You know, I'm going to move this down a little bit here. All right, so 40, that's going to be my mean for this. Now up here, we have the same variety of radish grown the same way but with fertilizer added, and the weights are also normally distributed, but the mean is 140. So we're going to put that up here. And the standard deviation is 40 grams, okay? So you'll notice the fertilizer obviously makes them much larger, but there's also a much larger spread. So it's possible to still get really tiny ones even though you have fertilizer, but it's possible to get some really huge ones with the fertilizer, okay? So in this case, with the fertilizer going down here, we would have 100, and then 60, and then 20, okay, for our 3 standard deviations. I'll put the 40 right in the middle, okay? And this is what our bell curve then is going to look like for the ones with fertilizer, okay? And then going this way, we'd have 180, 220, and finally over here 260. All right, and then this is what this side of the bell curve would look like. All right, the ones without fertilizer had a standard deviation of 10. So when we're going 3 standard deviations away, we're at 30, 20, and 10. So this bell curve is going to be pretty steep, like this, okay, comparatively. And then we have 50, 60, and 70. So it's going to go down like this, okay? So you have those kind of things, and you can just see here kind of the comparison that we could make. Then, at this point, you just have to keep straight which model you're using, okay? Without fertilizer, with weights less than 50 grams, that's going to be 1 standard deviation above the mean, okay? I won't do this for all of them, but basically we're trying to find all of that, okay? So what proportion of the radishes were grown without fertilizer with weights less than 50 grams. Well, one standard deviation above the mean is going to be 50% plus another 34%. So that would be, 84%. Okay. And then the ones with fertilizer that weigh less than 60 grams, here, notice we're 2 standard deviations below the mean, which means there's only another 2.5% down here. Okay? So we're looking for this area here, that's 2.5%. Okay? And the others are similar there. Okay? So the idea here, the biggest thing I want you guys to get from this, guys, is first of all, just recognizing the area and how to visualize this probability with the bell curve. Okay, I've seen multiple IB exams where they ask a problem not necessarily for what the probability is, but they'll say, hey, the probability that our randomly picked variable is less than X is 30%. Where is X? Or show on the diagram what probability we're talking about. So you would be putting something, less than 30%, that's going to be, somewhere in here, and then you're shading down, okay? So it should be a really easy couple of points on your IB exam. But that's what I wanted to practice at. The other thing is also just, even though we're going to learn here in a moment how to use our calculators to find these probabilities exactly, thinking about it in these terms can help you get at least a good idea of what your solution ought to be. It's a way to do a quick mental check. So for example, if we're asked, what's the proportion of the radishes without fertilizer whose weights are less than 55, that's between 2 of the standard deviations, but we know it should be a little bigger than 84%. Okay? In fact, it should be between 84% and 97.5%. All right, so if we get a result that's outside of that range, we know we did something wrong. Okay? So the better we understand this, the less likely we are to make mistakes when we are using our technology. Okay?
What about number 8? You don't have to do it, just how you.
Let's see, number 8. Oh, here it's recognizing the notation. Making sure we recognize the notation. When we're given this, what does this tell us about our data? First of all. Okay, it tells us the standard deviation. What is the standard deviation? 0.1. And then what else? What's the 3? That's the mean. Okay? So that's the mean. Now, part A here, part A, we don't even need that data for. Okay? Because no matter what data we're looking at, if it's distributed normally, what percent is going to be within 2 standard deviations of the mean? That's between 1 and 2. You're telling me, here's our mean 1 and 2 standard deviations. That's 13.5%, just that little piece. But they're asking us all the data between or within 2 standard deviations of the mean. So that would be the 95%. Okay. And then, what is the value of X that's 1 standard deviation below the mean? If our mean's at 3, 1 standard deviation below the mean. 2.9, okay? So if the mean is at 3, then 1 standard deviation below is 3 minus 0.1, so 2.9. Okay? All right. Now, like I said a couple times here, we want to use technology here to help us. Okay? We're going to look at a couple of different ways that we can use our calculators to find standard deviation or to find probabilities using our mean and standard deviation in a normal distribution. Okay? So first of all, get your calculators out. Make sure you have those ready. Okay? All right, so we've talked about this already in the sense that when we're talking about probability, we're talking about area under the curve. Okay? Probability is area under the curve. That's what we were just saying by shading underneath. Okay? And we saw the other day that this function right here is the function that gives us this bell curve for any given mean and standard deviation. Okay? Now, we did not graph any of those on our calculators. Okay? But I want to look at how to graph them first of all, and then how to use that graph to find different areas. And just so we know what's going on here, area under a curve in calculus, as we'll see later this year, is given by the integral. Okay? And because we're talking about probability, and this is a probability density function, we know that the entire area underneath this curve has to add up to 1. So, with your calculator, the first thing we're going to look at is when we're graphing this curve, rather than trying to punch in that whole function there and get all the parentheses in the right spot and not make any mistakes, we actually have this normal PDF function built into the calculator. Okay? The normal PDF function. Now, if you have the Inspire, it's actually just called norm PDF, not normal. Now, you can find this through the catalog. Okay? But you can, that's the one nice thing about the Inspire is you can just type in norm PDF and hit parentheses. Okay? Now, notice the things that you're going to put in here. And if you're on the 84, it may ask you for X, the mean, and the standard deviation. Okay? Otherwise, if yours is like the 83, it'll just be, it'll just have parentheses and you'll have to list the things in the correct order. This X, you want to type in as just an X. All right? So go to where you're graphing. Okay? So on the 83 or 84, hit your Y equals button. On the Inspire, go to the actual graph where you see the XY plane. And then we're going to insert that function. Okay. And right there where it says Y1, you can type in normal PDF. Okay? So we're going to do this where we have a mean of 5 and a standard deviation of 1. So we should type in we should either find the normal PDF in your distributions. Remember when we had binomial PDF and binomial CDF? It's in that same menu there. Okay. On the Inspire, again, you can just type in norm PDF. And then when you type it in, you're just going to put the X in that first spot, and then the mean is 5, and 1 for our standard deviation. So here we have it. We're going to go second distribution. The normal PDF is the first one here. Okay? We're going to put that in for Y1. Whoop. Wrong button. Okay? And then again, X, comma, 5, comma, 1, close your parentheses. Now, before you hit graph, you need to make sure you can actually see this thing. And that's where the window settings come into play. This is where you have to use what we learned yesterday and what we've been doing with probabilities to set a window that makes sense. Because listen, you're not going to be told what to set your window at. Okay? So, let's think about this. If we have a mean of 5 and a standard deviation of 1, what should we set our window at horizontally? What would get the whole part that's meaningful? Okay, up to 10? And how far down should we go? 0. Okay, 0. If we have a mean of 5 and a standard deviation of 1, that'll give us 5 standard deviations both directions, right? So, if I go to my window, I'm going to set it going from 0 to 10. Okay? Then I need to think about vertically. What do I set my window at? What? Okay. We could go from 1 to -1. Okay. We could go from 1 to -1 to 1. Okay. Now and that'll work. Will probability ever be negative? No. So maybe just so we can see the x-axis, maybe make it a -0.1. You can do 0 to 1. Okay. I like to do just a -0.1 so I can actually see my axis at the bottom of the screen. Okay. But now when we hit graph, we can see our bell curve, and you can actually see it decently well. Okay? Yes? Okay, what's it telling me? Okay, oh, you know what? You have a plot, you have one of those was turned on, so it was looking at your lists and seeing you must have had different things in different lists.
Okay.
All right, so that's the graph. Now, let's think about this. Let's say I wanted the probability, okay? I want to find the probability that a random variable is between 3.5 and 6. Okay? Now notice here, I have my windows set. This is what you should see without the shading, obviously. Okay? To calculate that area, like I said, we're going to use an integral. All right? Now the integral is found if you go at second calc. All right? It's above trace. And notice the last one here, number 7, is the integral of f of x dx. Okay? So we're going to hit number 7 to do the integral. Notice now it's asking us for a lower limit. Okay? It's under second trace. It's above trace. Calculate.
Okay.
If you're with the Nspire, you need to go to the menu and analyze graph is number 6. And then number 6 there is integral as well. Okay?
What is the function? It's second and then integral?
No, you'll do the integral, the last one on the list there. Okay? Now it's asking you for a lower limit. On the Nspire, it lets you kind of move the cursor, but you can just type it in. If it's not letting you type it in, yeah, lower bound, just type in 3.5. Okay? Okay, that's okay. Just hit escape and then cancels that out. Okay? And then go back in. Okay? Now, here's the thing. You want it exactly at 3.5, so just type in with your... Okay. Is yours letting you type it in? Okay. Now, yours, I think you need to hook up to your computer and do a little update. Okay? If your Nspire is not letting you type in values for your lower bound and upper bound, you need to do a little update. Type it, plug it into your computer, go to TI, Texas Instruments website, and look for an update. Okay? So I'm going to type in 3.5 for my lower limit, and then I'm going to go for my upper limit. We wanted it to go up to 6. And you'll notice now it's shaded the part that we're looking for. And notice here that the probability is given as the area. It's 77.77453754. That's 77.5% if you round to the 10th of a percent. This is why we're all doing it together, so. Okay? So, well, you just type it in. Type in 3.5. Yes. Yeah, because the likelihood of actually getting exactly at 3.5 is not very good. So. Okay. Anyone else having trouble getting it to work? Okay. So that's how we can get it with the graph. But there is a way we can do it without having to graph it at all. Okay? If we don't need to actually see the graph, we can actually do it using the normal CDF function. Okay? You guys remember when you had binomial PDF and CDF, the PDF gave you specific values and CDF was cumulative. Alright? PDF and CDF work a little bit different when we're talking about the normal distribution. What we will do is we're going to input 4 different values. Okay? Now, notice the order that you have to put these in. We're going to use the normal CDF, and we're going to do it not in the graphing, but we're going to do it back out where we're just calculating stuff. Okay? So we're going to put in normal CDF, then your lower bound, your upper bound, your mean, and the standard deviation. Okay? You have to put them in that order. So what we could do to do the same problem, the previous problem that we just looked at, instead of graphing and using the integral, we can go to second distribution and use the second option here, normal CDF. And our lower bound was 3.5. Our upper bound is 6. The mean was 5. And the standard deviation was 1. Now when we put that in, it gives us the probability right away. All right, so if you don't need to see the actual graph, then you can just use the normal CDF function. Okay? On here, you can just, on the nspire, it's just like the norm PDF. It's not normal, it's just norm, N-O-R-M. Okay? Yeah, on the nspire, it's not normal, it's just norm, CDF. Okay? I don't know why they changed the name between versions, but okay. And again, you can find it in the catalog, but it's easier just to type it out. Oh, instead of you put a comma instead of, I know, a decimal point. Okay. Okay. All right. Again, this is why we're all doing it together. Make sure we all know how to do it on our calculators. Now, one thing that can be a little bit tricky with this one is getting whole ranges of values. Like, what's the probability that x is less than, let's say, less than 4? Well, I don't want to do 4 because that's right on the standard deviation. Let's do 4.1. Okay? Well, you look at this and you say, okay, well, I have everything is going to be the same except for that 3.5, but I want to go to negative infinity.
0 point, negative 0 to negative 99999.
Yeah. You can just put some really low number, and this is where if you think in terms of the, how do you know it's low enough? Well, you could either do that and make sure it's low enough, negative 99999, or think in terms of your standard deviations. If I did a negative 10, that would be 15 standard deviations below the mean. That would be sufficient, okay? Or even if I just did a negative 99, that would be sufficient. And I could then get the probability is 0.84, okay? Or wait, I'm sorry, I had the wrong upper bound. Okay, so
it's 0.1.
4.151. Yeah, about 18.4%. By the way, hey, there's a good example where I knew I was below my mean and I got 84%, so I knew I should have had an answer less than 50. That's what tipped me off that I had punched something in wrong, okay? So pay attention to those things.